Yes, lah.
Okay, yeah.
Okay, so that is and then the glass comes in.
Yeah. Yeah. So it's, I think, minimal, I guess.
Few things. You are also one of the first team, maybe the other team they didn't mention that actually accurate or not accurate beside the point, that you all identify where are trees.
Yeah.
Okay.
Yeah.
That's
The
important.
one that we needed. Yeah.
That the form was dictated largely, correct me if I'm wrong, because of the position of the tree. So that's a good thing. Okay, just a side. So can you tell me a little bit about energy consumption? Because there's a statement there that says 2,060 panels to take care of. Is it all the energy needs? Do you say all? Is it energy or to take care of energy needs?
Yeah, the energy.
The energy needs.
Yeah,
So what is the energy need?
Which is the air conditioning.
No. I need numbers. Of course, your air conditioning. So was there some assumption? If you all didn't do the detailed calculation, did you all pluck some numbers from somewhere and then times your floor area? So can we have an understanding of why 2,060 and
Yeah.
not 3,000?
That's a good question, but the thing is, my the teammate who did the calculation is not here today to answer that. Yeah. But
Okay, fine. Then the other thing is, I mean, it's very pretty that you all put the solar panels like that, but in effective, you're going to put the solar panels in the design that you all lay out, then you all effectively did not use the roof space very effectively. Space is a premium in Singapore, so cannot anyhow use it. Remark, anything on it? No, don't worry. Have and you share. We are trying to. So other than solar panels, yeah.
We are trying to keep this calm.
Yeah.
Oh, so this is the water irrigation that will collect from the roof itself, and then it will channel down for the ravine area.
So is it gravity or by pump?
Most likely gravity because it's going down.
Anything else? So there's also grey water channeling.
Yeah. And lastly is besides that, we also have a green roof on the roof itself.
Didn't see.
Yeah, I mean, because it wasn't inside. So the detail here.
But if you all lay your solar panels like that, your green roof is not going to be an accurate display.
Right.
Yeah. If you all be more concise about how you all lay your solar panels, right, then you all have more advantage to deal with your green roof.
for the solar panel, right, I would like to add on that as much as the placement is like that, but then I felt that the solar panel should have more than just one purpose itself to just collect the sunlight. And like knowing the fact that the sun hits the roof the most, and I think like we just want to channel the wind and things like that. And the green roof on top is actually not really for normal people to go up, you know. It's more like to cool down the solar panel and the roof on top. And the water irrigation system from the side is actually to help water the plant that is needed at the side. Hence, like it's channeling downwards like that. So there's like I guess there is like water storage at the bottom if there's too much water to collect later on using for the plant. And solar wise, yeah, the solar panels on top to maximize the sun and the wind. Yeah.
Any other questions? Okay, thank you.
Thank you.
Yeah, okay.
I'm okay.
Yeah, okay. Then we continue.
Okay, then team 2. NYP team 2. Stand by.
Oh, so it should be good. Be careful.
Our next team is also from NYP, Team 2. They also collaborated with Chaoyang Uni and National United University. So guys, are you ready? You're still picking up the fun, huh? Okay. Okay, the flamingo.
Good afternoon, everybody. We are a team from MIP, as mentioned, and we are a team that forms with collaboration with our Taiwanese friend, but currently they are not around, but it's okay. So let me start on my presentation. So our name is called Flamingo Forest. I will let you know why is it called. So this, our group actually consists of architectural students as well as digital engineering students. So most of us is actually architectural students. Only one, which is our friend Bohan, is actually from the digital engineering. I'm sorry, it might take a while to do. Yeah, so now I'm talking about our concept, which is this. Now, during our site analysis and after that, we do not know like what to do, and then we came across with the flamingo, which you can actually see in bird park in Singapore. This actually is our mentor. We actually did a project like biomimicry, and this came about because the quality of a flamingo is actually the long legs, and although the legs looks very thin and very it's not steady enough, but it's actually able to withstand its own heavy weight. So we take this into consideration, and we want our building to have to look lightweight and to minimize the usage of material, but it's actually able to withstand the building's weight itself. And this is a sketch from our friend, from our team, that we want to achieve this kind of quality in our building, which is more openings, and the place is actually very lively, and you can see there is a lot of trees that we want to implement in our building. Because it's in Coney Island, everywhere is tree. We do not want to have we want to minimize our impact on the plants around. So we actually we did studies of the trees and the location of it, and we tried to build it around it, so we don't really have impact on it. This is how the process goes. So at the first place, we have one block. So after that, we start to break the blocks. We start to separate the areas, and this is to implement the ventilation, to maximize the ventilation throughout the buildings, and then to let our buildings to have receive the maximum amount of natural lighting itself. And the center, you can see, is the courtyard. We want to have a building that is because it's usually it's co-workers and they are actually from different companies, they didn't really know each other. So we want to have a courtyard to actually connect them together. So they are actually, although they are different, they are from different field, but they are actually together. They actually can have in this place, they can actually, in the courtyard, they can actually do some communication and maybe in future they can do some collaboration. And then we start to have the legs. The legs is our building is elevated up to because we came across with the kampong house and we elevated up because we want to achieve the stack effect. The video I will show it afterwards. And this is our DFMA. Our approach is doing the precast structures in the factory and build it on site. So we did some studies and we did some simulation and we know like roughly how it's going to look like in when you construct to site. We already chosen the material which will be the steel and aluminium because steel and aluminium is very cost effective and is lighter weight, so it's easy to transport to the site to build it on. And this is the joints and how it's gonna be constructed. This is the project flow that my friend will later go through. And the simulations for solar path performance, and this is our design options. At first, we start to design and it looks very bulky. So we start to improve by adding more windows and having more openings. And then we have the render. Then here we come our final design. You can see in our final design, we place this render because we want to as an architect, we want to make use of architectural elements we do not want to have furnitures around. So in this space, we want the co-workers to have you are in outside and you can relax, you can have connection in between with the nature and you can rest it on the staircase itself. And on the staircase, because it's different level, it can give you a different kind of spatial experience too. So, and this area is actually, we took the reference from the Dutch design where they actually use pond, the water to act as a cooling system effect. And then there will we implement one block because it's in 4 different blocks. So one of the blocks that will receive the maximum amount of sun will have solar panels installed to generate our own electricity, so our building do not rely on other sources of electricity in the Coney Island. And we did the demonstration for the virtual reality, which you will later see in our video, and the AR. This is the building clashes we did with the beam track. Because our building do not have too many piping, so there is no clashes in the building. And because our friends only came in Singapore for 1 week, so we need to make use of the social network and online platform which we use Google Drive to upload all our documents and keep everybody on track. And we use Line to communicate with each other. And our challenge is actually the communication. As you see, we do have 2 friends that don't speak Chinese, so I will be the translator to translate throughout the whole when they are 1 week stay in Singapore, and which the other one which is lack of time, where we face a bit of short because we do not have much time. The exact time we have is 2 weeks to do our project, so we face these issues, but it's okay, we are now here. And the knowledge and experience gained is actually we learn how to prioritize the work, and we know how to learn knowledge from each other because they are from different country and they learn things differently. So we pick it up from them and we work together, and working online is the key. And now we will go to the presentations board to go through about that. Sorry, it might take a while. Moving forward to our site analysis, we actually did the study of the trees, right? And then our design is actually elevated to tackle. We've seen a lot of like trees that is actually below 1 meter. So this elevated up design is actually to prevent us killing more trees and cutting them down. In our key floor plans, you can see that we actually zone all the offices and event spaces into we spread them across in 4 buildings. So this is to ensure that there is no we don't neglect any building when, like, let's say we zone the workshop into one whole building. You will get neglected sometimes because